Well, welcome to this online revision session for AQA M2, in which we will be doing the January 2010 question 6 on the topic of circular motion, where the speed is constant. Now, this particular type of problem should be quite familiar to you as a canonical pendulum with a mass of 4 kilograms on the end of a string of length 1.2 meters, and it rotates in a horizontal circle at a constant speed, and hence a constant angular speed of radians per second. And we're being asked to find the radius of this circle in the first part of the question in terms of theta. So you can see it's just a right-angled triangle with a hypotenuse given. The length, the radius, is the opposite side of that triangle, so the radius will just be given as 1.2 times the sine of theta. Simple, straightforward, 1 mark. Then in part B we're told that the angular speed of the particle is 5 radians per second. So remember, angular speed is what we would call omega. And so we need to consider the forces on the mass of 4 kilograms. Well, we know it has a weight, which is given as 4g. And we know that the thing that's holding it in place is this tension in the string, T. Bearing in mind this is at an angle of theta. And so we know that vertically resolving, the forces must be in equilibrium, and horizontally the forces contribute towards the force towards the centre of the circular motion, which maintains that circular motion. So if we resolve horizontally, we can see that the tension is given by T sine theta. Now, given the fact we're in circular motion, we know that that force must be equal to the force required for circular motion, which we know is either given as mv squared over r or as mr omega squared, both of those things being appropriate depending upon the situation and what you are given. Now in this case we're given the angular speed, so we will put this as being equal to mr omega squared. Now we know m, we know r, we know omega squared, so we should now be able to do some appropriate substitution. So T sine theta equals 4, and r is 1.2 sine theta, and omega is 5, so that gives us 5 squared. So we can see the sine thetas in this case will cancel, and that then gives us a value for t as being 5 squared is 25 times 4 is 100 times 1.2 gives us t as 120 newtons. Having got t, we can now do the bit where we resolve vertically, because we know when we resolve vertically that t cos theta must equal 4g, because the forces in that direction must be in equilibrium. If they weren't, we wouldn't have a horizontal circle. So cos theta must therefore be equal to 4g divided by 120, which is approximately 0.3 3, 2, 6, 7. So on your calculator you might have something like 32666. So then if you do inverse cosine, that will give you a value of theta as 70.9 degrees. That's to 1 dp. Okay, so where do your 6 marks come from? Well, resolving horizontally and using the expression t sine theta equals mr omega squared. That will give you a method mark and an accuracy mark there, an answer mark for this. Then substituting in the appropriate values and obtaining the value of t will give you an answer mark there. Resolving vertically, again, will give you a method mark for doing the resolving and an accuracy mark for what you then write down, and then obtaining the value of theta finally gives you one more accuracy answer mark there. Hopefully you found that solution helpful. For further assistance with your revision program, please go to the Further Maths Support Program website.